known is m times this one will be s squared times y and minus s y0 and minus y dot 0. Okay, and plus b s times y minus y0 and plus k times y, and this one will be equal to r. Let me define the Laplace of r of t equal to r. Okay, so this is r of s. Okay, so for this case, we have initial conditions, and so say this is, let me just make one. Okay, so say if this is a y0, and this is a y0, and this one, let me put into more generic. So let me call this is the y velocity v. Okay. So in this way, let me rearrange. So the arrangement will be equal to y times ms squared plus bs plus k, and minus s times my0 and minus myb plus by0. Okay, good, equal to r of s. Bless you. So now I want to get arrangement is this. So you can see y of s can be equal to r of s and m s squared plus b s plus k, and then plus the remaining s times m y 0. I think I do the last. I want to combine these. I want to have the y0 terms together. Okay, so let me do that. Combine one more time. ms squared plus bs plus k, and that will be y0 and sm plus b. Okay, and then I have the yv this term individually. That will be equal to, let me see this one here, ms squared plus bs plus k and m times y v. Good. This is the nature of the controls. Sometimes you need a lot of writings. Okay, but the writing is very repetitive. You good? Okay, now I want to complain, not to complain, explain. I want to explain the certain physics behind these equations. The first, the two terms are related to the two values. The two values are the initial conditions. Okay? This term is this term basically is, from this term we can find out the y over r equal to m s squared plus b s plus k. Okay, this term regarding is this. And in particular, next time coming over, I'm going to introduce this one. This is a ratio between the output and input. And that is, from this relation, we can see that is this one. This one is defined as the, this should be the first terminology given to you in control transfer functions. Transfer function, by definition, is the ratio between output and input by ignoring the influence of the initial conditions. Okay? If you have taken vibrations already, and here you should have more feeling, once you take the inverse Laplace transform initial condition, the two terms originated from ICs will be producing is the corresponding transient response. Once you take the Laplace transform, get into time domain, the two terms will be giving you is the transient response. This is true for all the dynamic systems in the universe. Okay, and this term once you take the inverse Laplace transform, this corresponding is the steady state response. Okay, if I have time, then I'm going to explain you in details. But right now, you can have your notes be taken is this. This one simply is corresponding is the transient. Okay, and then this one corresponding is the steady state response. Okay, by combining together, if you have, remember when you solve for differential equations, say x, say y of t will be equal to yp plus yh, right? One is homogeneous solution, one is particular solution. Do you remember that terms? Yes, you should be. Okay, you should have. This one corresponding to our term that is due to the influence of the initial conditions. Particular solution that is corresponding is our steady state. I will give you more details later on. Okay, but right now you simply just memorize that. Okay, so today we're up to here.